Hey everybody, so in this video we're going to look at how to factorize algebraic expressions. And I'm just looking at some simple examples, alright? So we're going to start off really just from the basics. We're going to look at what factorizing means. So factorizing is when we look at what numbers divide into a larger number. So if I look at the number 18, for example, that's a number that has a few factors. I could say 1 times 18 would give us 18. I could say that 2 times 9 would give us 18, or that 3 times 6 would give us 18. So 1, 2, 3, 6, 9, and 18 are all factors of 18. Another example might be the number 12. So 1 times 12 could give us 12. 2 times 9 could give us, 2 times 6 could give us 12, or else 3 times 4 could give us 12. So 1, 2, 3, 4, 6, and 12 are the factors of the number 12. Right, there won't always be 6 factors, but there will usually be at least 2. So when we're factorizing algebraic expressions instead of just constant numbers or normal numbers, we have to look at it in 2 stages. We're going to factorize the numbers, and we're going to factorize the letters. So first the numbers, then the letters. Now just for the first example I give you, I'm going to have one that has no letters in it, so we can only just focus on the numbers. So I'm going to look for the factors of 3 and 6. So I've been asked to factorize 3 and 6. So I'm just going to write out 3 plus 6 here. And then I'm going to think about what number divides into 3 and also divides into 6. So the largest number that really divides into both of those is the number 3. So I'm going to write that over here on the left hand side. Then I'm going to open up a set of brackets and I'm going to put 2 terms in here. Number 3 is going to go in here and number 6 is going to go in here, but they're going to look slightly different. So what I do is I think 3 times what gives me 3. The answer to that is 3 times 1. So 3 times 1 would have given me 3. And then 3 times what will give me 6, positive 6. So 3 times 2 will give me a positive 6. 3 times positive 2 will give me positive 6. So at this point now I've factorized it. I've kept the 3 and the 6, but I've just divided out 3 from each of them because 3 is the greatest factor that goes into them. If I did want to double check that I've done this correctly, well, I could just multiply 3 by 1 here. 3 times 1 give me 3. I could multiply 3 by 2 here, which would give me 6. Right, that's not what they've asked me to do. They've just asked me to do the factorizing. But I could double check by multiplying it. 3 times 1 does give me 3. 3 times 2 does give me 6 here. Again, it's not necessary to actually write that bit at the end, unless they ask you to check your work. This is where we're trying to get to. So like I mentioned in that example, I just factorized numbers only. It didn't include any letters. So we'll have a look now at a second example that does include a few letters. Right, so in this example here, just to start us off, I've got a couple of numbers and a couple of letters, but there's no number in front of this x squared. So we can't actually factorize the numbers here. The only factor we're going to have is going to be letters. And what we see here is that these do have a letter in common, and the letter is x. So x will divide into each of these terms. It's going to divide into x squared, and it's going to divide into positive 4x. So again, we're going to open up a bracket, do it in blue. We're going to have the greatest factor on the outside. So the common factor here is x, because x divides into both terms. Then we are going to put 2 terms on the inside here. So we can think to ourselves, x times what gives us x squared? And that should give us the answer x times x, because x multiplied by x will give us x squared. Then we can think, what about the second term? X times what is going to give us positive 4x? The answer to that is x times positive 4. So if we want to think back through this and check our work, does x times x give me x squared? Yes, it does. Does x multiplied by 4 give me 4x? And yes, it does. Okay, so we're going to have a look at one last example now. This one is going to have numbers and letters that factorize out. So we've been asked to factorize 4 times x squared plus 8 times xy. So if you look at the two numbers 4 and 8, think about what numbers factorize into both of those. 2 factors into both of them, but we're looking for the biggest number that factors into both. So that would be 4, because 4 can divide into 4 and 4 can divide into 8. So when we're drawing our brackets, we'll have 4 on the outside. You can also look at what letters divide into both of them. And if we think about that, x is going to be a factor for each one, because there's an x here in our 4x squared and there's an x in our 8xy. So on the outside we're going to have 4x. Again, we're going to have two terms on the inside. One that corresponds to our 4x squared and one that corresponds to our 8xy. So we can start thinking to ourselves then when we want to fill in the bracket. What do we have to multiply by 4x to give us 4x squared? Well, we already have the 4, so we just need to turn the x into an x squared. To do that, we will multiply it by an x. So 4 will stay as 4, and x times x will give us x squared. That means that 4x by x will give us 4x squared. If we want to think about factorizing our 8xy, well, let's look at the numbers first. So 4 times what will give us 8? The answer to that is 2. We already have our x, so 4x times 2 will give us 8x. But we do need a y here as well. So 4x times 2y should give us 8xy. 4 times 2 will be 8, and then we keep our x and our y. And for this one, it might be worth checking it out again at the bottom. Although this is the actual answer, we could do it on a rough work page or something if we're doing it in an exam. So 4x times x, 4 will stay the same. X by x gives us x squared. 4x times 2y will give us 8. We keep the x and we keep the y. So the 4 times 2 gave us 8. Then we keep the x, we keep the y. Again, this here is the actual answer. This is just our way of checking it. So it works out the same as where we started from. We factorize and then we multiply out the brackets, which is kind of the opposite of factorizing.